Hey, like my shirt today? This is one of my favorite shirts. This is my surfer shirt, and not quite the era I grew up in, the woodies and the longboards, but I really like this shirt. Anyways, today we're going to be studying simultaneous equations and using them to solve value problems. Now, I call them word problems. Mr. Wallace calls it simultaneous equations. Actually calls it system of equations, but that's what he means, simultaneous equations. And let me just show you how that works. In a child's bank are 11 coins that have a value of $1.85. The coins are either quarters or dimes. How many of each type of coin does the child have? Now, in this problem, there are two questions. And actually, in every value problem that I know of, there are always two questions. And the first question has to do with coins in regard to their value. And so, a quarter is worth 25 cents, a nickel is worth 5 cents. And the second question has to do with the number of coins without regard to their value. That is, I have a bunch of dimes and a bunch of quarters, regardless of what their value is. How many of each do I have? Now, our first equation is a value equation. That is, quarters and dimes are going to equal $1.85. Now, since we're talking about the value of a quarter, by the way, did you notice we're not using x plus y? You can if you want, and some people do that, and then they convert it back into quarters and dimes later. But we've talked about that before. That gets to be confusing, and you're going, well, wait a second, was x quarters or was it dimes? And you go back and look at your work. This way, Q, guess what? It's quarter. It's always quarter. P is going to be pennies, D is going to be dimes, N is going to be nickels, and that's the way this works. But what's the value of a quarter? How many pennies are in a quarter? That's right, the value of a quarter is 25 cents, and it's always going to be 25 cents. You're always going to have 25 in front of a Q. You're going to be doing a bunch of problems like this, and you're always going to put 25 in front of a Q when you're talking about the equation that relates to the value. Now, the second equation that we're going to do, I know I'm getting ahead of myself, has nothing to do with value, and we're not going to put 25 there. But this is the equation that we put together that has to do with value. And what's the value of a dime? That's right, a dime is 10 cents. So the 25 cents of a quarter and the 10 cents of a dime is going to give us $1.85. Do you see any problems with that? Well, the book said $1.85. The problem says $1.85. But are we talking about dollars? Are we talking about dollars here? No. What are we talking about? We're talking about cents. Now, if you wanted to make it dollars, just put 0.25 in front of there. Makes it a little bit more difficult, but you could be doing that. And are we talking about dollars here? No, we're not. We're talking about cents. So to keep everything equivalent, cents, dollars, I don't think so. That's right, it's not $1.85. We need to convert that into 185 pennies, 185 cents. So now we're talking about cents, and cents. Careful. That is one area where students mess up. And it's a real easy conversion. Just wipe out that little decimal point, and we're good to go. Now, we have quarters and dimes. And how many did we have? Well, the problem said we had 11 coins, and the coins were either quarters or they were dimes. We don't know how many dimes we have. We don't know how many quarters we have, and that's what we're doing right now. We're trying to figure out how many of each we had. But that question is without regard to the value. So let's isolate either Q or D. Now we don't want to do that up here, do we? I don't think so. That's going to get a little complicated. We could isolate this Q. We could isolate that D. Which one do you want to do? Okay, let's isolate the D. Bring all that down, and when you do, of course, switch the Q and the 11. And just like our previous two lessons, we're always trying to isolate one variable. So we could have isolated the Q, we could have isolated the D. We decided to isolate the D, and D equals negative Q plus 11. That's the same equation as up here. We've just rewritten it. If you wrote both of those on a graph, you would get the same exact line. And so let's insert it into the first equation. This is the second equation, so let's insert it into the first equation. Okay, in the first equation we had 25Q plus 10D equals 185. Here we have 25Q plus 10D, the value for D. We substituted that in, equals 185. Now let's multiply this out. And watch your negative signs. There was a negative in front of that Q, so 10 times negative Q is going to be negative 10Q. So let's add our like terms. 25Q minus 10Q equals 15Q. Get that 110 on the other side. Bring all that down. Divide both sides by 15. That isolates the Q, and 75 divided by 15 is 5. We have 5 quarters. So if we have 5 quarters, how many dimes do we have? We can insert that Q, that is the value for Q, into the first equation. That's a pretty complicated equation. Let's avoid that. Or we can put it in here. Let's use the second equation. That's right, Q plus D equals 11, so Q equals 5. 5 plus D equals 11. I'm not going to even bring that down. You know what the value of D is. That's right, 11 minus 5 is 6, and so we have 6 dimes and 5 quarters, and that is the answer to the question. They asked us how many of each type of coin we had, and that's the answer. Now, that's a coin problem. Sometimes they'll give you a problem where they're selling tickets to a concert and the tickets have different prices. There were 41 tickets sold for an event. Tickets for children cost $1.50 and tickets for adults cost $2. Total receipts for the event were $73.50. How many of each type of ticket were sold? Okay, so just like the coins, we're going to do our value equation first. And you could do the other equation first. The second equation is a bunch of adult tickets and a bunch of children tickets were sold without regard to their value. But let's do the value one first. The value of an adult ticket was $2. And by the way, we're going to do this in dollars because the numbers are so big. You could do it in pennies if you want, and you're going to come out with the same answer. But the value of the children's ticket was $1.50, or $1.50, 1.5, whatever you want to put in there. And the total value of all tickets sold was $73.50. And you can put that 0 behind the 5 if you want. It's superfluous. That means it's extra and not needed. So we learned a little vocabulary today, didn't we? And the tickets, without regard to their value, was 41. We sold 41 tickets. Some of them were adult tickets and some of them were children tickets. And just like our first problem, we have two equations. One with regard to value and the other without regard to the value. That's just the number of adult tickets and the number of children tickets. And that's what we're trying to figure out, is how many adult tickets were sold and how many children's tickets were sold. And you know what we're going to do? That's right, we're going to isolate that C, and so we're going to subtract A from both sides, and we're going to bring all that down. And C equals negative A plus 41. And we're going to bring the top equation down, and we're going to insert the value of C into it. Okay, and 2A is 2A. We'll leave that alone, and we're going to distribute the 1.5 into the parentheses right here. And we have 1.5A. And when I say 1.5A, you should know that 1.5 is the same as 1.5. So I'll say that for short sometimes. 61.5 is 41 times 1.5 is 61.5, and that's what we have. Let's add our like terms. 2A minus 1.5A is 1/2A, or 0.5A, and let's get that 61.5 on the other side. Bring all that down, and 5A equals 12. That is 12.0, which is 12. Wait a second. You forgot to bring that decimal down. Don't forget to do that. That's a real easy thing to do, is drop in a decimal like that, and that's obviously going to give you a different answer. And I don't know, 12 divided by 5 is not going to be a whole ticket anyway, so you can't have that. By the way, if you make a mistake like that, just know, well, you can't sell 2.5 tickets, so that isn't right. So go back and see where you made your mistake. And you forgot to bring that point down. Good, and divide both sides by 0.5. And that will isolate our A, and 12 divided by 0.5 is 24. Is 24. Wait a second, it was 12 when we divided it. You're not used to that, are you? When you divide a number, it gets smaller. That's what you're used to. That's not always true. If you divide a number by a number less than 1, you're going to actually get a bigger number. So be careful when you do that, because it'll seem like you're making a mistake. So we started off with 12, we divided 12, and 12 got bigger. It got up to 24. And that is the correct answer for the adult tickets. And let's insert that into the second equation. A plus C is 41. A, that is the value of A. A plus C is 41. Let's get those units on the other side. And that's getting too low on our board to bring down anymore. 24 minus 24 is going to be 0. And 41 minus 24 is going to be 17. So we sold 24 adult tickets and 17 children's tickets. And that is the answer to our question. Now let's try a problem with stamps. A man has a collection of stamps made up of 5-cent stamps and 8-cent stamps. There are 3 times as many 8-cent stamps as 5-cent stamps. The total value of all stamps is $3.48. How many of each stamp does he have? Okay, and this is going to be the same thing again. The first equation that we're dealing with is a value equation. And I don't have nickels and quarters and dimes and stuff that I can put letters up there with. There's stamps and stamps, so I can't put S and S. So there are different kinds of stamps. There's a 5-cent stamp, F, and there's an 8-cent stamp, E. So let's put a value of 5 in front of the 5-cent stamp and an 8 in front of the E for 8-cent stamp. And there you go, we have our value equation. Now let's work on the other equation where we just have a certain number of stamps without regard to their value. Oh, you caught me. That's right. Cents, 5 cents, 8 cents, $3.48. So we got to get rid of that decimal, don't we? That's right. If we're going to talk about cents here and here, we need to talk about cents here. And $3.48 is 348 cents. So let's do it that way. Now, in our previous problems, they said that we had 11 coins, 41 tickets. And here, they're not telling us how many stamps we have. They're doing it by giving us a relation. And so when we have a relationship, we're going to write it like this: E equals F. And a relationship is we have 2 times as many of one thing as another. We have 7 times as many. It doesn't matter. In this equation, we have 3 times as many 8-cent stamps as we do 5-cent stamps. And it sounds like that 3 should be in front of the E. 3E equals F. That's incorrect. If we have 3 times as many of this, then to get it equal, we're going to have to multiply this by 3. Think about that. What's the bigger number? 3 times as many 8-cent stamps as 5-cent stamps. What's the bigger number? This is the bigger number. So to get it to be equal, we're going to have to multiply this by 3. Good, we're going to write it just like that. And so if you ever come across something like that there's twice as many of one thing than the other thing, then put the twice, the 2 times, next to the other thing, not the first thing. Is that confusing? Well, if it is, play with some numbers. I always like to play with numbers. If E was 15 8-cent stamps, well then 5-cent stamps would have to be 5, right? 15, 5, we have 3 times as many of that. So what do we need to do? We're going to need to multiply that 5 times 3 so that it's equal to the number of 8-cent stamps. And that's just me. I like to play with numbers in my head, pretend numbers, to kind of check to see if I wrote the equation down. Because if you didn't write the equation down, you're not going to get the answer correct. But anyways, this is real nice, right? We don't know what E is up here. We don't know what F is there. But we do know what E is here. E equals 3F. So why don't we insert this value up here? So 5F and 8E equals 348. 5F plus 8E equals 348. And what does E equal? It equals 3F, which is we already saw. So let's multiply that out. Pretty simple. And 5F and 24F is 29F. Let's divide both sides by 29. That isolates that F, and 348 divided by 29 equals 12. We have 12 5-cent stamps. And let's bring the second equation down because that looks a lot simpler. Oh yeah, very simple. E equals 3F. E equals 3 times 12, which is the value of F. 3 times 12 is 36. And we have 12 5-cent stamps. And we have 36 8-cent stamps. And that is the answer to our question. And that is how you do value problems. And you should be able to do all of the value problems in your homework. Now your homework is divided up into value problems and percentage problems. So don't do the percentage problems yet, but definitely do your homework.